Hello everyone, welcome to Bodha Academy. I am Kamlakar, lecturer in physics. Today we'll discuss about concepts and formulae related to circular motion. Angular velocity. It is nothing but rate of change of angular displacement. So it's given as omega is equals to d theta by dt. In terms of time period, angular velocity is given as omega is equals to 2 pi by t. In terms of frequency, angular velocity is given as omega is equals to 2 pi f. The relation between linear velocity and angular velocity is given as v bar is equals to cross product of omega bar cross r bar, where r bar is radius vector. The directions of v bar, r bar, omega bar are as shown in figure. Instantaneous angular acceleration is given as alpha is equals to d omega by dt. That is, it is rate of change of angular velocity. Relation between linear acceleration a bar and angular acceleration alpha bar is given as a bar is equals to alpha bar cross r bar, where r bar is radius vector. Various types of accelerations which we will be discussing circular motion are angular acceleration, which is nothing but rate of change of angular velocity, linear acceleration or tangential acceleration, which is nothing but rate of change of linear velocity, centripetal acceleration or radial acceleration, which is given as a is equals to v square by r, that's also equals to r omega square. The directions of angular acceleration alpha, tangential acceleration at, radial acceleration ar are as shown in figure. The resultant acceleration due to tangential and radial acceleration is given as square root of ar square plus at square. Let a body be moving with uniform angular acceleration alpha. Let omega I be initial angular velocity of body. Let its angular velocity changes to omega f in time t seconds. Let theta be angular displacement in this time. Then the equations of motion for rotatory motion are given as omega final is equals to omega initial plus alpha t. Omega final square minus omega initial square is equals to 2 alpha theta. Theta is equals to omega I into t plus half alpha t square. They are similar to v is equals to u plus at. V square minus u square is equals to 2as. S is equals to ut plus half at square. So these relations will be using in linear motion, whereas in rotatory motion, linear velocity is replaced with angular velocity, linear acceleration is replaced with angular acceleration, displacement is replaced with angular displacement. Centripetal force. It is a force that is directed radially towards center of circle. Its magnitude is given as F is equals to mv square by r. It's also given as F is equals to mr omega square or F is equals to mv omega. Suppose a body of mass m is tied to a string and is drilled in a horizontal circle of radius r. Then tension in the string is given as T is equals to mv square by r. That's also equals to mr omega square. Centrifugal force. It is a pseudo force that is directed radially away from the center of circle. Example, a coin is at rest on a rotating circular disc. Then static frictional force will balance centrifugal force. In such case, we get mus mg is equals to mv square by r, or mus mg is equals to mr omega square, where mus is coefficient of static friction. Consider a cyclist moving on a curved road. Let the cyclist be moving with a speed v and let r be radius of curvature of the road. Then he leans at an angle theta with the normal. In such case, tan theta is equals to v square by rg. Banking of roads. Consider a car on a banked road. Banked road means rising of outer edge with respect to inner edge. We call it as banking of roads. So you can observe that outer edge of the road is raised by a height h when compared to inner edge. This is done so as to minimize overturning of vehicles on the curved roads. Suppose if friction is not considered, then tan theta is equals to v square by rg, where theta is angle of banking. If friction is considered, then mu plus tan theta divided by 1 minus mu tan theta is equals to v square by rg. Consider a point P on the path of projectile. At point P, the radius of curvature is given as r is equals to v square by g cos alpha, where v is velocity of the particle at that point P and alpha is angle made by the velocity with horizontal at that point P. Conical pendulum. A small sphere suspended in a string fixed at a point and whirled in a horizontal circle. Then such an arrangement will form a conical pendulum. In conical pendulum, if r is radius of circular formed, t dash is tension in the string, theta is angle made by the string with vertical, then tan theta is equals to v square by rg, angular velocity omega is equals to under root g tan theta by r, time period is given as t is equals to 2 pi into under root r by g tan theta or 2 pi into under root L cos theta by g. The tension in the string is given as T dash is equals to square root of m r omega square whole square plus mg whole square. Thank you for listening. Do share and subscribe.